Hello, this is STEM Time from the Houston Public Library. I'm John Cooper. Today, we're going to talk about lunar eclipses. On Wednesday, May 26, 2021, there'll be a total lunar eclipse visible from Houston in the pre-dawn hours. We'll talk about what's happening and how to view it. You won't need any special equipment to view a lunar eclipse, but you will need to do some planning. Also, if you're a young person, you'll need to work with an adult. You're going to be out in the dark, possibly some distance from home.
Now, why is this happening? We see the moon because it is lit up by the sun. When the moon is on the same side of the Earth as the sun, the lit up side is facing away from us, and we don't see it. That's called a new moon. When the moon moves towards the side of the Earth, away from the sun, we see more and more of the parts of the moon that are lit up until there is a complete disk, a full moon, and then the moon moves back towards the sun. This cycle takes about 29 and a half days. So none of this is to scale. If it were to scale with the moon about 1 inch wide, the Earth would be about 3.6 inches, and the sun would have to be 32 feet wide. The Earth and moon would have to be about 8 feet apart from each other, and the Earth and Sun would have to be about 2/3 of a mile from each other. I also don't have access to a small nuclear fusion reaction, just a small LED lamp, so there's that. We can see the full moon because it's offset above or below the ecliptic, the plane on which the Earth revolves around the Sun. The plane of the moon's orbit around the Earth is offset from the ecliptic by about 5 degrees. This is not 5 degrees. It's more than that. It's simply for demonstration purposes. You should know that the orbital plane of the moon doesn't change its orientation very much as the moon moves around the Earth and the Earth moves around the Sun. It does change in a slow process called precession, but that happens over thousands of millions of years, and we're not talking about it today. Because the moon's orbit is offset from the Earth's orbit around the sun, it's only when the line where the moon's orbital plane and the ecliptic plane line up with the Earth and the sun, like so, that the moon can cast a shadow on the Earth, causing a solar eclipse, or the Earth can cast a shadow on the moon, causing a lunar eclipse. This means there's an opportunity for a solar or lunar eclipse about twice a year.
This season's solar eclipse will be an annular eclipse. The edge of the sun will be visible around the moon, but it will also only be visible near the North Pole from parts of Canada, Greenland, and the Russian Far East on June 10th.
The eclipse will begin with the moon moving into the penumbra, the light outer shadow of the moon, and 3:47 a.m. Central Daylight Savings Time. The moon will begin to disappear at 4:44 a.m. as the moon moves into the umbra, the deep cone of shadow behind the Earth. As the moon is covered in shadow, it will become easier to see the dark portion of the moon lit red from light refracted through the Earth's atmosphere. This is sometimes called a blood moon, and it's weird, freaky, and metal, and my favorite part of the eclipse. But there are some catches. The moon will move into total eclipse at 6:11 a.m. and out of total eclipse at 6:25. But the moon sets at 6:28, and the sun will be rising through this time. You may not be able to see the full blood moon effect if there's too much light from twilight.
Also, the moon's set time is based on when it falls below the horizon. It may be obscured by trees and buildings before that. If you want to view this part of the eclipse, it's important that you find a location with a clear view of the southwestern sky. This picture, taken facing southwest, has light, trees, and buildings obscuring the horizon. We're in a flat built-up area, so you have to do some looking for a spot with minimal artificial light, trees, and buildings in the direction you need to look. Scout for locations in the daytime. And look to the southwest to make sure you have a good, clear view. Think fields, parking lots, pedestrian bridges. This view, also taken facing southwest, is just a few hundred yards away from the first, but there's no artificial light, and trees and buildings are out of the way. Even with these caveats, it's going to be a thing to see. So, do yourself a favor, go to bed a little early on the 25th, wake up early on the 26th, and look to the southwest. From about 4:45 on, you're going to see something really, really interesting. There are a lot of good resources out there. For young people, I would especially recommend The Moon Book by Gail Gibbons. I'm personally indebted to the charts from the NASA Goddard Space Flight Center at eclipse.gsfc.nasa.gov. Many of those resources were produced by now retired NASA astrophysicist Fred Espenak. His website is Mr. Eclipse, MrEclipse.com. Both of those sites provide information about eclipses generally, as well as information about past and upcoming solar and lunar eclipses. I found the relative sizes and distances of the Earth, Moon, and Sun from Space.com and Universe Today. Both sites have a variety of articles on astronomy, ranging from introductory materials to information about specific astronomical events, such as this eclipse. Thanks for joining us for STEM Time at the Houston Public Library. Make sure to share photos of your project or eclipse viewing online and tag us using the hashtag #ILoveHPL. See you next time!